Okay, welcome to Huawei's Useless Mathematical Finds, or WUMF, whatever it's called. Alright, now I noticed this when I started doing centroids or whatever it's called. Since these are sketches, these are not going to be accurate at all, but I'm still doing it. Now, once you do a centroid of a triangle, it's kind of looks like a TP, but once you do a centroid of a triangle, you will notice that there are 6 new triangles. Now, what I've observed is that you can keep doing this. And I do this quite a lot because it's fun to do, in my opinion. And once you do them, you get something that looks roughly like this. You can continue doing all these triangles without it taking too long. Now, from what I've noticed, I call these triangle semi-fractals. The reason I call them semi-fractals is because although they have the potential to become infinite complex shapes, which is what a fractal is, another feature of a fractal is that no matter where you zoom in, it looks almost like the whole image, which this does not, because if you'll go into a corner, you'll probably find an infinitely long isosceles triangle, at least in the scale ratio compared to this, so I'm calling it a semi-fractal. Now, the most detailed I've ever gotten one of these to get is probably this, which is a compilation of 3 triangles added together, and I then added the centroids 4 times over, which is where you get this weird thing. Anyways, that's all I have. One last thing I forgot to mention is that you can actually calculate how many triangles are inside of the centroid motherboard type triangle if you apply this formula. X being the amount of times you calculated the inside centroid triangles. Anyways, that's all I have. Please correct me if I have any information wrong, or if you would like to add anything of your own relating to the subject, post it in the comments.